This is our sulfuric acid. 98% ultra pure sulfuric acid.
In this video, I'm going to make pure 98% sulfuric acid from distillation of lab battery acid. I got more than 400 mils from distillation. Here's 2.3 kilograms of battery acid with a concentration of 37%, which can be purchased online, and we're going to distill all of these. Never forget to add some boiling stones. Many liquids tend to be overheated, including sulfuric acid solution. Let me show you what is bumping. Here I was heating the test tube filled with water. Overheated means liquid doesn't boil, even its temperature rises over its boiling point, and after a sudden it starts to boil, you have a hot sulfuric acid rain in your lab, just like Venus. Addition of boiling stones keeps you on Earth. Use an additional funnel to add the remaining 1400 mils of sulfuric acid during distillation. I do not recommend batch addition, because if the solution stops boiling, the boiling stones may lose its function. The whole apparatus is shown here. I use simple fractional column to increase the efficiency of separation. Although it's not necessary to use it, when the difference between boiling points of each component are not within 80 degrees Celsius, sulfuric acid loves water so much, so that using a column increases the yield a lot. Let's do an experiment to visualize fractional distillation process. I placed some dichloromethane and bromine in the flask and let it boil at 40 and 59 degrees Celsius. Obviously, the fractional column cannot separate two liquids with 20-degree difference between their boiling points, but you'll see. Attention! You need reflux condenser to do reflux while doing fractional distillation. The job of the fractional column is to only increase the contact surface area between a liquid and gas, as well as to slow down the flow rate of reflux liquid. The column should be well heat insulated in professional fractional distillation, and the reflux ratio is also controlled. We're going to compare the color of bromine vapor at different points in the column. Now, the system will reach equilibrium at full reflux condition. Let's compare the color at the top and the bottom of the column. You can see the color at the top is slightly lighter than that at the bottom. The column was doing its job, but far not efficient in this case. How does fractional distillation work? Let's take, for example, what I'm doing here. Let's say we're currently distilling 40% sulfuric acid, which boils at 113 degrees Celsius, but the vapor the mixture gives contains a higher concentration of water. Supposing the vapor is 10%, as vapor reaches the condenser, it cools to 102 degrees Celsius first. Then it condenses to liquid and drips back down. The 10% condensate meets 10% vapor. Things happen. Every system wants to reach equilibrium. Condensation and evaporation happen all the time at the boundary between liquid and vapor. When the content and the speed of condensation and evaporation becomes the same, the system reaches the equilibrium. For instance, 113 degrees Celsius, 40% sulfuric acid will reach equilibrium when the vapor above it is 10%. For the same reason, in 10% acid vapor atmosphere, liquid tends to become 40%. That 10% condensate will eventually lose some water to gain sulfuric acid approaching 40% if there's infinite 10% vapor and drip back down to the distilling flask. The 10% vapor will lose acid and gain more water, becoming more water concentrated and travel towards the top at the same time. The cycle repeats again. If a liquid gives off vapor that is the same as the liquid, for example the purest substance or the anisotropic mixture, fractional distillation won't change anything. 98.3% sulfuric acid is an anisotropic mixture, and this is the highest concentration we can get from distillation. There are more details on the internet, so go and do some research if you're interested. I didn't use a condenser especially for reflux cause the apparatus would be too high to build. The fractional column can be used as an air condenser at the same time, but the efficiency will be lower. In fact, you can actually conduct the experiment without fractional column, but you'll get less concentrated acid and more dilute one. I stored this part of distillate, which should be very dilute acid, in an HDPE, high density polyethylene bottle. After 5 hours of distillation, I started to see fumes in the flask, and that's because we're getting a decent concentrated sulfuric acid. A small amount of water dripping down from the fractional column can now react explosively with hot acid we have now. These explosions cause the flame, but don't worry about the flame. As long as it's condensed vapor, the fume will go with the product instead of air in your lung. The fluffy stuff covering the glass were made of aluminum silicate, preventing too much heat dissipation from apparatus. Many people like to use aluminum foil as heat insulator, but to be honest, that doesn't do anything. Using high temperature blanket is the right choice. The thermometer is showing 120 degrees Celsius, which means we're getting around 48% sulfuric acid at this point. I stored everything coming out from 105 to 120 degrees Celsius in a glass bottle. Boiling stone. Well done. It's over. Liquid addition is over. Yes. Finally. Almost 1 o'clock now. Jeez. Okay. Your job is finished. Additional funnel. After I finished dilute acid addition, I kept distilling it until there's no more water coming off. Concentrated acid's boiling point is high enough to all be condensed by the air in the fractional column under the design power of my heating mantle. After it cools down, colors. The next night, I set up a similar distillation apparatus to distill the concentrated sulfuric acid. I used a 30% 30 centimeters long air condenser in the first trial. Then always at the boiling zone. Okay, let me tell you something first. I got some technical problem on the first 2 trials. If you want to see what the problems were, please keep watching. Or you want to watch the final successful one, please just skip. As you heat the sulfuric acid from room temperature to its boiling point, the liquid expanded a lot. That's why you shouldn't fill your flask too much. I used a small flask to collect the relatively dilute acid first, and then switch to the big flask. There is some problem. Look at this. 98% sulfuric acid boils at 337 degrees Celsius. Using fire blanket to keep the heat from dissipation, or almost all the acid were condensed before reaching the condenser, unless you have a nuclear reactor. No way. One of the problems was the particles from the blanket went in the glass joint and caused a small leakage. Secondly, the single air condenser is not efficient compared to the high power distillation. This 500 ml heating mantle is 300 watts at 220 volts. The rubber on the clamp was burning. As you see on my infrared thermometer, the condenser was way over 200 degrees Celsius. I need a stronger condenser. I had no other choice but stop the distillation and let it cool. The next day afternoon, on the second trial, I used the method that I used a year ago. A straight condenser, hot fill of water, because the latent heat of vaporization of water is huge. It won't take too much water to condense the acid vapor. Another thing I did is using Variac to feed 286 volts to my heating mantle, so that I will get 500 watts to speed up the process. Well, the result was the condenser cracked.
A layer of water.
Because the high power heat had to pass through the small area of glass
See the crack?
and cause high temperature gradient. Some water went into my sulfuric acid as a reward.
Damn it.
Piece of shit. The same day, night, I used a long adapter as an air-cool column and monitor the temperature of vapor using thermocouple. A spiral condenser is attached to the column to slowly cool down the acid. I also kept providing it with 500 watts of power so that the distillation would be faster. I also washed away the blanket particles stuck between the glass joints so that there shouldn't be any acid vapor leakage. Using small flask to collect everything that boils below 328 degrees Celsius shown on the thermometer and change to a larger clean flask. I only let water fill the third of the condenser and using a large jar as reservoir to keep the water level as constant as possible. That way, as water boils inside it, steam will pre-cool the upper part of the condenser. If you take a look at the distilling flask, well, my heat mantle is glowing. Was at red hot state. And we're getting our sulfuric acid. Let's see temperature at different points. 321 Gs, 304, 307, 294, 168, and 69, 50. Excellent. According to this temperature result, we know the majority of vapor condensed and released large amount of heat before reaching the condenser to become liquid acid over 300 degrees Celsius. Then, the spiral condenser cools the acid all the way to 50 degrees Celsius. Nothing cracked now. There's almost nothing left in the flask except some stones. One way to test the concentration is measuring its density. I placed 10 mils of concentrated acid I got. Well, the density was 1.84, which is excellent. In conclusion, I turned 2.3 kilograms of lead battery acid to 1 liters of pH2 sulfuric acid, 400 mils of 16% sulfuric acid, 200 mils of 40% sulfuric acid, 25 ml of 67% sulfuric acid, and 400 ml of concentrated 98% isotropic sulfuric acid. If you choose to not use the fractional column, you'll get less and more dilute one. There's a simple test for my concentrated sulfuric acid. You just, mix with sugar. That's all for this video. Thanks for watching.